Again, I'm Rich Simmons. For those joining online, we're back again to talk about charging infrastructure with this panel. What I wanted to note here was in our little prep session with the panelists that Trey helped us convene, we realized there is a lot of uncertainty in the world today, and that was mentioned earlier this morning. We also realized a lot of optimism among the speakers that you're going to hear from next. And that's really wonderful to see and something that we want to continue. And so I'll start with this sort of charge for this session. It was the best of times, it was the worst of times. We're going to look at that from 4 different perspectives here in the next hour. And I think, as I mentioned at the top of the day, the thing I love about SETRI, that we can sit on a panel with an academic institution, a finance perspective, business investment, charging company initiatives, and utilities here in one session within 1 hour. You have the big meetings of your own stakeholder groups where you hear from all the utilities, and then all the NGOs, right? And then all the commission staff. And then all the academics get to sit off and put on their nerd hats. We're going to mix it up here a little bit. So I have the privilege to kick it off. I have just a few slides myself. I wanted to start with that note about the value added of SETRI. Hopefully that's resonant throughout the day, that we're going to just keep sitting next to people we don't normally sit next to. And talk a little bit about a couple of studies that we're doing, a cohort of studies, a study that I'm part of. Much like the work at Alabama, we want to get the word out, and we want to get your feedback so that we know that we're studying the right problems on the university campus, and then that we're also building the right pilots, because we have a unique opportunity. It was mentioned in the morning about the campus goal at Duke of being carbon neutral, which is a huge achievement. Congrats to you. And how we do that is also by developing learning labs, use those labs for research, and then let students learn, and then we engage the private sector and the people at the front line. So about 5 years ago, coincident with the launch of SETRI in the background, Georgia Tech decided to carve out about $700,000 over a couple of years and fund legitimate 1 to 2 year projects. It was a competitive round, so we did our own sort of grant project. I was the pioneer of the funding proposal, having spent a lot of time doing this as the researcher. We architected a program. We awarded this money to 6 teams. Really privileged to have Professor Leamy in the room. Could you raise your hand, Mike? He's one of the recipients of one of the grants. He's also full-time faculty at Georgia Tech. And if you want to know more about his project, talk to him after. He can also tell you how well we did as far as running the grant round. But the point was to really do what we thought the university's role should be, which is connect with researchers across the value chain, provide thought leadership, skate to where the puck is going to be, not where industry's already pretty well along, but where there's a gap, where there's a need to address misunderstandings, to educate, to test modeling. And so that was the goal of the overall project. Here is a summary of the 5 projects that went to the full 2.5-year term. The point is 5 projects, 2 on smart charging. And that's the really neat area where we said, look, there's this weird thing that happens when people have a signal. So that's the study that Dr. Leamy is leading, said, you put this great EV bonus rate out there where people get a super discount at 11 p.m. Unfortunately, everyone then takes advantage of that, and there's this sort of grid challenge. And whereas you thought that was a low peak period, now you have this big response happening to take advantage of the lower price. And so looking at randomization and so forth, that was an opportunity. There's another group looking at recycling of materials and batteries. Is it worthwhile energy-wise, emissions-wise, cost-wise, to take them all the way down to the bare, cobalt, manganese, nickel? It's a pretty energy-intensive challenge. And so this team was looking at repurposing cells in a module that may be no longer performing, that still had some viable life, repackaging and repurposing. So for second use, I saw Alabama's doing a second use project. I know others are. And then sort of eventually making the decision to what recycling methods are appropriate to get down to the materials, and then where is the value back. There's another one about electrification of urban areas that may be threatened by natural disasters. So this is more of like a 20 or 30 year challenge where we say we would get to double-digit, really significant share of the transportation fleet is electric, and yet we now need, along the Atlantic seaboard, this is in our mind, to evacuate, right? And there's this double whammy. The grid goes down and we're in these electric vehicles. So that was the nature of that study. And then another one on sort of micro-mobility. So check those out. That was something that we did. This is a slide showcasing some of the work that came out of Dr. Leamy's work. They actually have a patent pending, and they developed a smart charger that could be modular and work with sort of universally with other systems. And then we also did a cohort, in addition to that vehicle grid, we've done one on health and energy. I won't go deep into that. It's not as germane to this topic, but it was another area where Georgia Tech Energy and in partnership with Emory and the EPA, we said, what are some of the things we should be thinking about the intersection of air quality, renewables, fossil, and some of this touch on more urban type of analysis. Now briefly, a study that I did in funding with the DOT through their university transportation centers. I said, we really need better ways of estimating the carbon and energy profiles, signatures of electric vehicles. We think that they are zero emission, and that's not necessarily wrong if you draw the boundary around the vehicle. But obviously, you've got to plug them in, and normally you're plugging them into something that's not 100% zero carbon. So there may not be emissions at the tailpipe. There are certainly system emissions. So this was a study, and I won't go into great detail. It was a 2-year study. But what we wanted to say was, when do people charge? This is an example just for the Georgia Tech public chargers, 42 chargers showing when they plug in on campus, how long their sessions last. We converted that to sort of a simple algorithm of charging profiles. You could do it at home, you could do it in the evening or overnight, you could do it at the workplace, showing the duration needed for the typical state of charge replacement. And then thinking about what's up behind the meter, right? So where is this power coming from? What is the utility putting on the grid to meet these loads at different times of day, different seasons of the year? It's obviously more extreme sensitivity in the winter and summer peaking events, and also in the afternoon and depending on the season, it could be morning in the winter. And that really then dictates what the profile of our EV vehicle mile traveled translates to. And so what we did was we studied the hybrid vehicle, the internal combustion vehicle, in contrast with all these different assumptions about how you're charging, when you're charging, what the grid is producing. And I won't explain it all, but the red dot here is the hybrid baseline, and the purple dot is the internal combustion baseline. So in each of these cases here. And then the others are the scatter plot of how you could come out on the EV side of the ledger with a very comparable vehicle. And what we see is that when we compare to those baselines, EV has a very uncertain sort of emissions estimate. If we're saying EVs are important for decarbonization, we have to be more mindful of how we're thinking about when to charge and of what duration. This level 3 challenge is even more significant, because if it's a very fast 1-hour event, it could be a gas peaker that's on the margin, as opposed to potentially hydro that we can basically bring on to meet the need of the grid. So these are 2 reports. I'll let you look at them later if you like. And then very briefly, a kind of a picture gallery of some of the microgrid and energy resources that we're looking at my lab. This is a large lead acid battery that's just been installed. We're commissioning it. We're cutting the ribbon in about 3 weeks. And that will be used to store photovoltaic energy that's also on the same building. The battery sits behind this building, and we can then like shift the solar at a certain scale that's appropriate, 300 kilowatts for the solar array, 150 kilowatt hour battery. And then that's in conjunction with the new EV charging test bed that we have, where we would like to talk to campus fleet. We know that thanks to some others in the audience, the Georgia Tech Police Department now has electric vehicles on their fleet. And what we want to talk to them about is, could we think of testing modes where vehicles are not in high demand in the night, but solar is not there? Can we use that battery as a way of shifting that over and certifying a more clean pedigree? And then finally, we have a new battery center that we're setting up fundamentally to look at chemistry, talk about applications. And then finally, I just want to remind us what we're here to do and give a charge to the next three panelists in order. They'll kind of do the same thing, give you a flavor, and then we'll have a Q&A. What is the value proposition right now? What are the role of studies that we do or anyone does? How can pilots help? And broader expansion of the SETRI umbrella. So with that, I want to turn it over to Electrata and Ben Rogers, and then we'll go to Emily and Tom. So the green one.